I'm Andrew Finlayson and I work as a geoscientist for the British Geological Survey. I'm working on Virkisjokel Glacier using ground penetrating radar to look beneath the surface of the ice, and I'm doing that to pick out the bed of the ice, so that tells us how thick the glacier is, but we're also looking to find layers within the ice, and these are thrust planes or fracture planes, and these are important because they tell us how the glacier is moving but also how water is flowing through the ice. I'm using ground penetrating radar. It has a transmitter unit which sends an electromagnetic pulse down into the ground. Where the electrical properties of the ground changes, that wave or that pulse gets reflected and sent back up to the receiver unit. We can then use the two-way travel time, the time that it takes for the pulse to get sent and picked up, to work out the distance that it's travelled to the layer beneath the surface, and that helps us image these layers over the entire glacier. On Virkisjokel, I'm working closely with Emrys Phillips. Emrys is measuring the structures, looking at the structures on the surface of the glacier. I'm using the radar to pick out the structures beneath the surface of the glacier so that we can combine those data sets to build a three-dimensional model of the internal workings of the glacier. We're also working with Mike Rains, who's using geophysical techniques to look at the thickness of the ice and also look at the rocks beneath the ice. So again, we can combine all those techniques together to build up a three-dimensional model of the whole catchment that Virkisjokel sits in.